did. Hope you had some rest tonight and you digested the food. Now we're in the business of starting the last day, and you're halfway through your own mini symposium. I hope you have exchanged enough ideas to continue with today. We have a plenary lecture for this mini symposium. I think it's a nice opportunity that people get to know what it takes to get what they're using, like cars and airplanes. And the speaker is Dr. Roberto D'Ippolito, who is the ex officio coordinator of the project. And you know what that means. That's why he's getting sick very often, and also for a lot of other business. And there is a limitation to physical strength. And he's from Italy, and he graduated from the Aerospace Engineering Department of the University of Naples. Federico. I didn't know that, because then you must know my very good friend and colleague, Professor Lecce.
Of course.
Okay.
One of the heads of my department.
I was there 2 months ago because we have been testing a model of a new airplane with open rotors for noise control. But now back to Dr. D'Ippolito. He has a solid background in process integration and design optimization. And that's part of our conference objectives, optimization, because no matter what you do, you end up doing optimization. One way or the other. Robustness and reliability. Probabilistic modeling of structures with more than 9 years of experience, with reliability-based design optimization, engineering mechanics, and composite materials. He has more than 50 publications and is currently the function of Research and Development Manager for Noesis Solutions and partly for LMS International, with a special focus on forward research activities. This forward research activities, it sounds light, but it's a very heavy business. It keeps you up and on your toes. So I guess, and asking for forgiveness for my delay, let's get started. Dr. D'Ippolito.
Thank you.
Of course, you can take this.
Shall I speak from?
You can do it either from here or you can take it and
Yeah, I think it's long enough. Thank you very much, Mr. Chairman, for this introduction. It's my pleasure to start this plenary session. Thanks a lot for the invitation and for giving me this chance to speak about a little bit problems and challenges that most of the companies that I have been talking with and that are working with us have nowadays in product development processes that are particularly knowledge intensive. So, scope of the lecture this morning, of this speech, is to give you an overview of what we see as the main challenges and what type of solutions we can propose to address these challenges with the iProd context. As probably some of you already know, iProd is an EC funded project with 14 partners and including research institutions, companies, universities, and industry. I'll try to start with laying down a little bit the context of the project and of the industrial challenges that companies are facing and that we are trying to address. So normally many EU companies, since it is an EU project, we focus mainly on EU companies. Nevertheless, these challenges are global challenges. Many of them have ambitions, targets, needs to conquer domestic markets, to be to export to foreign markets, to deliver best quality products, to create and maintain brand name and brand image, to reduce the time to market, and eventually also to become market leaders, or at least to have large shares of the markets where they operate. In order to do this, there are some ambitions, some objectives. You need to launch a competitive product with a good performance, with respect to the requirements that the customer has specified, at a reasonable cost and time. And this comes through a number of topics, I would say. This to beat the domestic competition, meet the expectations of the customer, export and internal regulations, which are always constraining our products in some way or another, launch on time, and increase quality of the product development process, so make everything better and possibly on time. This is normally linked to two factors, one internal, one external. One is company driven, the other one is market driven. So we have company driven and market driven necessities. These necessities relate to engineering, setup of the processes that are related to the manufacturing, increase the know-how, keep it in-house and increase it, implement the right tools, manage the risks related to the product development process, and possibly reduce as much as possible defects and late fixes. This is also linked to market-driven requirements about what the customer is expecting, what do they want, what is their ambitions, what is the competition doing. We are not market stakeholders. That means that many of them are related to other players in the market, translate expectations into engineering processes, and shorten the time to market. This generates a lot of data, a lot of information related to the product and to the process that needs to be managed. So all these constitutes what we call heterogeneous data. A typical example of a car is pretty easy. There is a customer perspective that perceives the car or the product in a way that is subjective, that is not quantifiable yet with engineering tools. But on the other side, there is also a way to engineer the quality. So make sure that these expectations then are translated into something that can be quantified, measured, and verified. So this goes through the typical V process. We all know that. That starts from preliminary design with the definition of requirements, conceptual designs, very high level designs that then get refined slowly down to functional components, systems, and then down to the very small component. So detailed simulation, detailed processing, and then up again to validate that the whole process and details have been, thank you, that the whole process and all the other details are verified and validated. So this normally it's a closed loop approach, that at some point some items go back to the conceptual and restart the process till convergence, till physical prototypes or virtual prototypes make sure that everything is consistent. These are typical, I mean, if we want to summarize them, these are typical industrial challenges: time, cost, quality. These are well known. Huge amount of data that is generated that needs to be analyzed, managed. Limited amount of resources, time, computers, people, and a lot of knowledge that is created that is probably not retained within the company. So what are the consequences? That normally we are pushed to do less with, to do more in less time with less people, and need to keep this knowledge in an efficient way within the company. Then there are ICT environments which are also not helping to shape up this thing. We have partitioning of the knowledge and of the software tools, lot of big investments in big PLM, PDM systems that most of the times lock you in their environment, in their framework. A lot of costs related to licenses, to software tools, maintenance, management, hardware sometimes. Very manual-driven processes that make the whole thing quite cumbersome. So the consequence is that most of the knowledge is spread all over the company, fragmented in a number of small parts, and not accessible to everybody. Most of the times, even not accessible anymore after a while to the same users of the computer. So too much time is spent in doing repetitive work, in doing things that have been already solved maybe just a few months ago. So, but what is actually needed, what is actually required is retrieval of information in terms of requirements, structure, virtual and physical verifications, so that they match specific targets that, that the product needs to meet. Information should be available, up to date. Information should be also made aware to all the players in the company, and standardized in a way that everybody can understand it at the best that they can. So at some point, all this information needs also to be used to take decisions, to go ahead, to step back, or to go for specific choices at some point of the development process. All this goes through a very simple word, which is product development process automation. We'll see this a little bit later, how we intend to address these challenges. So if we make a summary of all these challenges and wrap up all these major items, we can say that the product development process is one of the less formalized processes in a company. It's known, but it's not formalized or structured in a formal way. There is a huge amount of data that from different sources passes through the different levels of the company, from the very bare simulation up to the business processes. The methodological product development is not integrated yet. That means that even if there are a lot of ICT solutions that support this, all these solutions don't talk to each other in a nice integrated way. And I would say that such an integrated approach is not yet existing. As a consequence, the knowledge of the PDP is present, but it's only available in the head of the experts. If the experts leave the company, knowledge leaves the company as well. And still, this impacts a lot the cost of the product development process with too many physical prototypes and or virtual prototypes that still have a quite large impact in the total costs. So, what are the objectives, the challenges that we have to face eventually at a broader level? We can say that all this boils up to two items: managing complexity and heterogeneity. So making sure that we can manage more complex and sophisticated products and processes and keep all this information consistent in a single place. So we know that the product development process relates essentially to two items. One is product knowledge, the other one is process knowledge, which is associated to the product. Product knowledge relates to customer expectations, performance trees, physical and virtual tests, etc. While process knowledge relates to the way you do things, more than what you do. The way they do things and relations, activities performed, tools and domain specific knowledge. If you are an aeronautic company, you have knowledge about your tests, about the processes that you need to do to certify your components. But all this knowledge is normally distributed around the overall product development process. This is also related to a tendency that we have now in the engineering context, which is the convergence of three different big items. One is clearly the physical world, so where we need to deliver our products and possibly test them. We have the engineering context, where design and modeling of the products is done, and the management of services and logistics to make sure that the whole value chain is working synchronized and delivering the things on time and with a sufficient quality. So you can be the best company in the world, but if your supply chain is failing, you are also delayed. This deals mainly with the complexity, so making sure that your product gets more sophisticated and close to the physical world as possible, and heterogeneity, because engineering and management of services produce so much data that sometimes we are not even aware of. And all this data contains a lot of information that is just wasted, not used. So I would say that the challenges that we should address in the mid to long term are management and heterogeneity, management of complexity and heterogeneity, both for the products and for the processes. Here we have a lot of tools that are very good in doing specific things, like ERP systems, PLM systems, PDM systems, computational infrastructures like clouds, HPC. But the missing element is cooperation mechanisms between human to human, human to machine, and between machines. That is, we know the concepts, but we don't make the relations explicit enough to work for us. Challenges of complexity are pretty clear and evident. So complexity resides in products and processes. Most of the problems get more complex because they become multi-physics, multidisciplinary, with high dimensions, more features, large models. Yesterday there was, at the beginning of the conference, there was an interesting talk from a person from Airbus that was exposing the Crescendo results, the Crescendo project results, and clearly there the behavior digital aircraft, the famous BDA, is definitely falling in this context. It's a very high dimensional, very complex, interrelated, full aircraft that needs to be simulated. Now the industry has really put a lot of money in this direction in the past years. We cannot neglect anymore that even a washing machine is now becoming distributed in the approach. This, however, faces the fact that these procedures of interoperability are not formalized. That means, okay, yes, I know that I have to contact my colleague that is in next door, or next department, or in the office in another country to get this information, to get some knowledge, to make sure that I'm interfaced, etc. But this is not happening in a standard way. So we don't know how this information is retrieved, and it's always particular and specific to a special way of working, essentially. And the solutions that we have in this sense are not scalable at all. Still, computing resources are difficult to use. Even if we want to make this thing happen, there are issues with ICT domains, security, where the information is, where it is delivered, and even cloud computing is an alternative, but it's not a solution. On the other side, there is heterogeneity. There is still a lot of data that is produced out of products and processes. All this data is segregated in different CAD, CAE, PLM, PDM test solutions. Even the fact that we distinguish between these tools is a way for us to simplify the fact that we are putting data either in CAD, either in CAE, either in PDM, etc., but it's not completely integrated. It's not interexchangeable. It's not in a standard way. And this locks us in specific vendors, like big vendors would like to do. And whenever you are within this environment, everything works fine, but the soon you want to step out of this environment, you get in a lot of troubles. So in reality, it's very difficult to integrate and put all this information together, and ad hoc solutions are not solving the problem. They are probably just making it a little bit more complex, or addressing only very specific item in the complexity. In this way, so the knowledge that you put in your models or in your tests and information is fragmented and separated from each other. So whenever you want your model or a model of another department, getting it is taking a lot of time. Knowledge management, as we discussed it also a few days, at the beginning of the conference, is the key item here. So you need to manage the knowledge of your company, whether it is a model knowledge, it is engineering knowledge, it is a design rational knowledge, product knowledge, process knowledge. All these things need to be managed, detected, extracted, stored, and reused. Easy to say, but very difficult to do in practice. So one of the things that we may be proposing today with the iProd approach is a way to sort out the bottlenecks of heterogeneity and complexity. Let's be clear, it's not the holy grail. It's an approach that helps out to sort out a lot of these bottlenecks and facilitate the integration. So it's a way to fill up the gaps between implicit and explicit knowledge. Maybe it can be that you already have found the solution of your problem, but till the solution is not made explicit, you are not aware of it. Avoiding consistent information about the product and the process. So make sure that when you do a change in one thing, this change is detected and reflected also to other items. Between, like, I don't know, you change more requirements, what this requirement is impacting in your product, and change only that. And possibly don't do 2 times the same mistake. If I designed my aircraft rudder one time, why, and I have chosen a specific solution, why should I redo this thing again 2 times with the next product for the next aircraft? If I know that one solution is good, then I can just inherit this knowledge, retrieve it, use it for myself, do small modifications, and adapt it to the new aircraft, which is already done partially in many companies, but it's not made formal and explicit. So also getting this information requires asking the right questions. So overall, if we want to translate, I would say, this vision to the concrete reality is that the objective of manufacturing successful and competitive products boils down, I would say it's a simple thing, but it's very complex, to an integrated product development process framework, which takes resources, tools, processes, and knowledge. So in order to answer to this question and how we can face these challenges, how we can address these challenges, clearly we need to spot where knowledge is in the product development process, where we need to look at. Clearly, when we start a new project, we have a product that we need to design, whether it is aeronautic, automotive, or whatever other, electronics, even services or embedded services, embedded tools. Always you start from definition of requirements, either your or external or a mix of them. You analyze these requirements, trying to make them more engineering oriented, so pass from a subjective view to an objective view. Use this objective view to prepare your work. This tells you what you need to do and plan the tasks. So make a first draft of your plan and say, okay, I need 3 months to do that. How can I arrange my resources and tasks and dependencies, etc., in an efficient way to do my work? Then you start to design, so to do effectively the development of your product. And these, once you proceed and you do verification steps. So I do my design, I create the first prototype of my rudder. Is my rudder, is my car, is my suspension working as expected? I do mock-ups, I do tests, I do verifications. Yes, no, I collect all these elements, put them together, and validate. So make sure that what I wanted to design is actually what I have now in my hands. And it is doing. Clearly this is a loop, so it's closed, and knowledge is in each of these steps. And if the validation is failing, then clearly you have to restart somewhere again. Otherwise, you are done. But the whole knowledge that stays in this round trip, I will say, needs to be spotted. And if we want to look at what is inside, we can see easily that we have a lot of knowledge that at a high level is stored in each of these steps. Competitors, requirements, alternatives, specifications, product structures, verification of the requirements, bill of materials, design norms, product structure again, parameters, performance achievement criterions, key performance indicators, a lot of other stuff. So what to do to address these challenges? What we put now on the table is one of the possible solutions. We think it's smarter than a number of other solutions that have been proposed in the past, because it uses technologies that have been not used before in other contexts. These technologies relate to a special way of knowledge, managing the knowledge. The knowledge that is, we know, stored in PLM systems. They are well known. I mean, between Enovia or Siemens or Teamcenter, I mean, there are a lot of tools outside there. ERP, Enterprise Resource Planning and Management Solution, Enterprise Service Buses for ICT services, a lot of legacy tools that are laying up on our desk, like Excel, Word, databases, FE solvers, web services, or even tools that I write up myself, like a macro